Hi, in this chapter, I'd like to show you how to draw RC circuit, RC circuit using Tinkercad. Okay, on the home page, what you have to do is just click here and circuit. Then you see this whiteboard. So now you go to component on the right hand and you see basic. I like to go all, and you see all this model. So now what I like to do is I like to get breadboard. So let me use this breadboard, okay? And this one is this is large, so I like to use this one some. Okay. But, so this one I'm going to erase it. Then I'll use this one. I'd like to see, like to rotate. Okay, and then maybe smaller. I use a control button with the mouse. And after that, I like to use power first starting from power supply, right? So instead of power supply, I like to use a function generator. So function generator here. I like to put two inputs, which is a 10 volt and 5 and minus 5 volt. So 0 to 10 volt or minus 5 to 5 volt. So I'm going to use this to function generator. Then after that, let me move a little bit down. After that, I like to put some this oscilloscope and another oscilloscope. This for the input, and that one is for the output. Then I like to have a multimeter. This is just for voltage across the RC, and then another for current. Okay, so now let me put some resistor and we rotate resistor. And, okay, slide switch here, so you can select one out of these two. And one R, this is in here. Okay, and after that, I can connect that one. Or C, so I just connect to one side and rotate. Okay, so to rotate this one, if I press the shift, then I will go the other side. Otherwise, you're just going right hand, right? So, okay, so now the breadboard, all these pins connected. So let's just move here. So that way, this one is connected. Okay. And then that one is, let's see. So I'm gonna connect this one. Okay, and then um, this one is negative. Okay, so this has been connected negative. So I need to connect all this jump. So whatever um, starting from power. Let me put some power for red line. Okay, so this is this red line, right? So there's a power source one and go to slider. Okay, so it goes in it, and that one so that goes to that goes to here. Mhm. Okay, so it's been connected. Okay, so it's been connected. Now, for this is slide switch. This one, just either way you select it on out from either source will go to the, let's see, a bit longer, I'll connect it here. So that means like all this line is connected. Okay, now obviously for this oscilloscope for this one is also um, connected to there. Okay, so now this one is power line, and like to measure the, or look at the output. And so now this output, this one is gonna be, okay, so that's power source. So just connect it here. Then it's gonna supply to here to there. Okay, and then now this is plus. So I'm gonna connect this plus to measure the voltage cross resistor. And then also this one power, I want to connect this one for the oscilloscope and go there, and connect the positive. Okay, so it's positive. And then this one now, I just connect all the positive and we connect the negative side. So now we connect negative, and then as you see, this is negative, and yeah, I go there and jump together, connect there. Then again, from connect here, and then now it will just connect to the breadboard. Okay, so breadboard plus and minus is now connected in. So now plus that go there, and then that negative will provide um, we should go provide the power to the, Okay, so this one. So power is coming from here, the positive input and negative output coming down there, provide the resistor, okay? And then again, now you want to measure this one here, negative. So you can go. This one you like to measure across across so get it, and I want to go certain. See, this one is let me check it. This one. Okay, so let me see this one. You go around with this one. This one has to go connect to there. Let me connect to the. Let me connect to the here together. Because that it goes to this one, the voltage across resistor, and now after that, like this negative is also connect to the connect to the yeah, connect to the here. Right, so now you see the measure over here, and then adjusted all the um, instruments. So let's see, that one we're gonna 1,000 hertz. Okay, so 1 kilohertz is fine, and amplitude is this one. I'm gonna put some 10 amps, 10 volt, and then the offset, D offset is 5 volt. Okay, then this one frequency, same frequency, but I say this one is 5 too, and the offset is 0 volt, so they weigh from 5 to minus 5 volt, and also scale rate. Then now this one it will be plus and go through here, so it provide this is current. So I'll make it this one measure the current, and so you adjust this one as an amperage is current, and this one is voltage. That's correct. Now this one is instead of 100, let me put some 0.25 millisecond, and the same as 0.2 0.25, so 0.25. Now for the also this one is voltage, so we're gonna go still across this plus minus. So we know now this one is plus minus connected. This is plus minus connected, and This one is connected. So all this one is connected, all this one is connected. So now it's ready to go simulate. So let's see. Okay, so I'm going to use this to stop simulate. Let's see. Okay, now we can see all this display from 10 to 5 volt. See, from here, input. So now, as you see, that 5 to 10 volt means offset is and then now as you see right now is this one is you just put the slide switch, you can tell this one is 5 to 5 volt, and then this one is you go. Okay, so now you can just change all the inputs, and from 0, then you can just you can see simulation that what it look like, and based on this information. Okay, so now the value over here, this one is, as you see, is a resistance 1 kilo ohm. So I like to change to 10 ohms, and then this is 1 microfarad. Okay, so it's 1 microfarad. Okay, so now based on this one, okay, so trigger, you see now this input and output. As you see, because of low capacitance and resistor, the time constant is low, so that's why we don't see much slope at the beginning here and then after that. So now if we change the value of resistor, let's see here, we're going to change it 60, then you can tell more like a stop. You can see now more angled, right? So more, you can see time constant. And then now resistance are changed to, let's say, 1,000. Okay, then you see now like a so to output, right? And even like a 10,000, then you see it's changing too. So through simulation, you see the voltage is now changing. Now, as you see, the current through the circuit is very low, actually 0. It's almost like milliamps. So that's why they're showing it 0.0 volt. But however, if this one is 10, then you see they start showing 161 microamps, very low, even though 10 ohms. Okay, so now also you can change it through here, change it to that one. Then accordingly, you just change the output. Now you can change the resistance like from 10 to 60. Okay, and you see the change here. And now, again, you can change it to You can change to 1,000, 1,000 or so like it. Now if we add one more zero, make it 10,000, then you see a more even sharper angles. Okay, so this is how the circuits look like, and output response to the input. So today, just simple, and I hope you understand. Thank you.